Hello, thank you for tuning in to our video today regarding the spirometer. I'm going to show you how to create a calculation in SparkView so that you can measure the lung volume during your spirometer experiments. I'm starting on the home page of SparkView. You can see that I already have my spirometer connected to a SparkLink and then to the computer, because you can see the measurements that the spirometer has of flow rate, total flow, and max flow rate appearing on the screen. So I could click any one of these and select Show to get a display, but what I want again is to be able to calculate lung volume. That's going to be a very common measurement in a spirometer experiment, but is not one that you can directly choose from the home page. So I'm going to select Build. And here I could select a sensor measurement and a couple different ways to view that data, but what I'm looking for is the calculated data tool. So I scroll to the bottom and here I've got calculated data and I'm going to create a calculation. I'm going to type in the calculation and then I'll take a few moments to explain it. So I've given my calculation a name. I'm calling it lung volume, and it's equal to V0 minus the measurement of total flow. So you might have noted that when I did this calculation, I selected measurements, and I was able to select total flow from measurements. Now when I click return, it's going to ask me to define V0. This is what's called the functional residual capacity, and for many individuals this will be right around 2.5 liters. So as a person breathes normally, just inhaling and exhaling at a normal rate, there's a large amount of air that their lung has the capacity for, but is not actually being moved during that inhalation and exhalation. So that's the functional residual capacity, the volume of air that remains in the lungs during normal breathing. So I've defined what V0 is, 2.5 liters, and that's just a general guideline for most individuals and should work for your labs. Notice I did not put a space between lung and volume. The name that you give your calculation needs to be all one word. I'm going to click back up next to total flow, and I want my lung volume to be in liters. So I need to define that as the property of this calculation. So you can see lung volume as my measurement. I'm going to click the keyboard for units, and I'm going to replace the general default word units with the unit that's specific for this, which is liters. So I can click done, and if I scroll down to calculated data, you'll see I now have my calculated value of lung volume in liters. So I'm going to select lung volume. You'll see it highlights in orange when I've selected it, and I'm going to choose a basic graph display. So this will give me lung volume over time. And I can click OK and see that display. So now I'm going to go ahead and collect some spirometer data. The directions for the spirometer use tell you to go ahead and begin data collection with the spirometer mouthpiece resting on the table. So I'm going to do that right now. It's just at rest on the table. And there are two lights on the spirometer sensor. Initially, the red light will blink and it says wait. And then shortly after that, the green light will blink and it says ready. So when it says ready, I can pick up the spirometer and I can hold the tapered end of the mouthpiece in my mouth, kind of holding it between my teeth and letting my lips form a seal around the spirometer. And I'm going to just take normal breaths, making sure I breathe only through my mouth and not through my nose. So I did a couple of things during data collection. I started out just breathing normally, And then I did a maximum inhale followed by a forced exhale, and then returned to normal breathing. So you can probably see on the graph display, at about 35 seconds, I started to breathe through the mouthpiece, and you can see the lung volume change as a result of that. But in order to get a better view of the data, I'm going to use my graph tools and the auto scale. And then you can see those changes in volume more clearly. Now, the normal breaths will give us information about something the scientists call tidal volume, while the maximum inhale followed by a forced exhale gives us additional information about vital capacity and forced expiratory volume in 1 second. And these are values that would be important when analyzing, say, a person with asthma and whether or not a treatment is improving the lung functioning of that person with asthma. In part 2 of this series, we'll go ahead and take a little more time to analyze this data, but now you've seen how to set up your spirometer with the calculation for volume and how to begin data collection.